Hello everyone, welcome to another new video. Here in this video we are going to start a numerical related to the soil moisture and crop relationship. So you can see here we have a question here. This question is uh, taken from the world question, and this question is asked in Pokhara University 2024. Okay, so in this video we will uh, solve this numerical we have here. Okay, so let's start the video. Okay, so let's see the question. So compute on the depth and frequency of irrigation required for a certain crop with data given below. We have given some data and we have to determine the depth and frequency of irrigation. Okay, and we have given data root zone depth equal to 100 cm. So let's see given data. Let's write here root zone depth equal to 100 cm, and the field capacity equal to 22%. So given field capacity equal to 22% and wilting point equal to 12%. Okay, so we have root zone equal to 100 cm. I have already written here, and wilting point, that is PWP, equal to 12%. Okay, simply the wilting point is denoted by PWP. PWP means simply the wilting point. Okay, and it's given here 12%. Apparent specific gravity of soil equal to 1.5, and the specific gravity of soil is given over here 1.5, and consumptive use equal to 25 mm per day. Okay, and so here consumptive is equal to 25 mm per day, and efficiency equal to 50%. Okay, so this is the data given. Now we have to determine the depth and the frequency of irrigation. Okay, so before solving this numerical, let's see some concept related to the soil crop relationship and the relation between duty delta and crop period. Okay, so let's see here. Okay, you can see here I have written the relation between duty delta and crop period. Okay, so simply delta is denoted by this delta. Okay, and now we will see different relation. Okay, and before this, if you are new to the channel, please do subscribe the channel and like the video and press the bell icon, so you will get regular update. And I have uploaded different numerical of irrigation engineering. Okay, so you can visit our channel, and I will keep a link in description box. Okay, so you can visit from there too. Okay, so we have, if the volume of water applied to the crop for B days, if B is the volume of water applied and for the B days, okay, then we can simply calculate volume equal to discharge into time. Okay, so for discharge, Q into T, and the value of Q into 2 equal to 1 into 6 into 6. Okay, this is after calculating time in here the time is in day. Okay, for the converting day into second, then we have to multiply 24 hour into 60, then it goes into a meter, and after multiplying 60 it will be in a second. Okay, so we have multiplied by 60 into 60 into 24 into 1, and simply the B is in days. Okay, so this converted into second, and now we have calculating this value, we get 86400 B. Okay, this is in meter cube per second. Okay, so this is the volume becomes in meter cube. It means simply volume equal to 86400 meter cube. Okay, now we have to calculate the total depth of water applied on land. So it can be simply calculated by the volume by area, total volume by total area. So we will get the depth of water applied on land. So we have total volume equal to 86400 B, and area equal to 10 to the power 4 D. Okay, this is in a hectare. So we will get the value of this becomes, after dividing this value 86400b by 10 to the power 4, we will get 8.64b by d, okay, in meters. So you have to remember that here the delta is in cm and b in always in day, and d equal to hectare per cumex, okay, cubic, okay. And by the definition of delta, okay, so I will show you what is the definition of delta. You can see here, delta is simply the ratio of total quantity of water that is in hectare meter to the total area of land, as I told, okay, and water depth required for the crop during entire base period. If the entire quantity applied of water will spread uniformly on the land surface, the depth of water would have been equal to delta, okay. As this definition, we can calculate the delta, and thus the delta in meter of average crop can be determined by deriving the total quantity of water in hectare meter required by the crop area land in HA. So as we saw, the definition of delta equal to total depth of water, okay, that is delta, and the total depth of water we have already calculated, that is 8.64 b by delta. So we just keep this value over here. So the value of delta becomes 864 b by d in cm, and whenever take in meter, the value of delta equal to 8.64 b by d in meters. Okay, now let's see the solution of numerical. So let's see, we have given this all data, okay. Now we have to calculate the value of AMC. So simply the value of AMC can be calculated by the dividing of wilting point, field capacity minus wilting point, simply field capacity minus wilting point, okay. Simply the value of AMC can be calculated by subtracting wilting point from the field capacity. So we have given over here field capacity equal to 22%. So we just keep the value 22 minus wilting point. The wilting point value is 12%. So we have to divide subtract this value, then the value of AMC becomes 10%. Okay, so we have calculated the value of AMC, that is 10%. Now whenever we calculate the RAM, then we have to simply multiply this value with the efficiency. So for calculating the value of R, we have to multiply with the efficiency of this value, okay. AMC times efficiency, just simple, okay. So we have the value of AMC equal to 10 we have the value of AMC equal to 10%, and the value of efficiency we have given in the question, that is 50%, and the efficiency equal to 50%. So we have to just take the value of efficiency in decimal. So the 50% means in decimal 0.5. So we just multiply 0.5 efficiency with the AMC, okay, and the value of AMC is 10%, and we get the value of RAM. This RAM equal to 5%, okay. So we calculated the value of RAM. Now we have to calculate depth of water available for consumptive use. So depth of water available equal to gamma dry into depth D into RAM by gamma of water, okay. Simply we have to divide by gamma of water, then gamma of dry we have to take 1.5, and in question is also given here. You can see here the specific gravity of soil, okay. Simply you can see here the apparent specific gravity of soil is equal to 1.5. So we have to take gamma of D equal to 1.5, and depth equal to 1, and RAM we have already calculated the value of RAM equal to 5%. 5% means simply 0.05 in decimal. So we have taken this value 0.05, and the gamma of water, as we know, gamma of water is always taken in 1, okay. So the gamma of water is taken to 1, then the value of depth of water available becomes 0.075 in meter, and here we have taken this all value in meter. That's why the calculated value is also in meter. so 0.075 meter, and converting this value into mm, we will get 75 mm in mm. Okay, so depth of water available for consumptive use we have already calculated. Now simply we can calculate the irrigation interval equal to this depth of water available 75 mm with by the total 25 days. Okay, so I will show you here. So the value of irrigation interval becomes 3 days. So now we have taken for this 75, that is the value of calculated depth of water available for consumptive use, and it can be divided by consumptive use, that is we have given here 25 mm per day. Okay, so we have to divide for this value, and we have to multiply with 1. Okay, sometimes we have to multiply with 1.2. Okay, so that's depend on condition. Okay, and you can simply take 1 or 1.2. So after calculating this value, we get irrigation interval equal to 3 days. Simply 3 days means we have to irrigate the land in every 3 days of interval. Okay, we have to supply water. We have to supply water or irrigate water in every 3 days interval. Okay, simply it means that now we can calculate depth of water equal to 75 by 0.5. Okay, so this is the, we have to for the depth of water we have to divide with the efficiency. Okay, so we have efficiency equal to 0.5, so just we divided with this value, and the value becomes 150 mm. Okay, and we already calculated the value of depth of water available equal to 75, so we just divide this value with the efficiency, because we know efficiency equal to input by output. And you can say this like as the depth of water available at consumptive use. Okay, depth of water available at consumption used to the depth of water. Okay, so after using this formula you can calculate the depth of water, and the value of this becomes 155 mm. Okay, so this is what asked in the question to calculate depth and frequency of water. So we have calculated depth of water equal to 150 mm, and we have efficiency equal to 50%. Okay, so at last we get the value of irrigation interval equal to 3 days, depth of water equal to 150 mm, and depth of water for the consumption use becomes 75 mm. Okay, so that's all for this numerical. So I hope you guys will understand. Thank you very much, and in next video we will solve the second numerical. Okay, and this numerical is asked in Pokhara University 2019 fall. Okay, in this video we will solve this numerical. So stay tuned. Thank you very much. See you in next video. Please like the video and subscribe the channel and press the bell icon so you will get regular update. Thank you very much. See you in next video. Okay, if you have any queries, please comment down below. Okay, I will definitely reply. Thank you very much. Hello everyone, welcome to second numerical of crop relationship. And before this video we have already done one numerical related to this chapter. Okay, we are studying soil moisture and crop relationship, and we have already done this numerical asked in Pokhara University 2024, and in this video we are going to solve the numerical of world question that is asked in Pokhara University 2019 fall. Okay, so let's see the solution of this numerical, and I strongly recommend please visit the first numerical, and I have explained the different concept related to this chapter. Okay, so after visiting the first video you can understand this second numerical very easily. So you have to first see the first numerical, and I will keep the link of that video in description box. Okay, so you can simply visit from there. And I have uploaded different numerical of irrigation engineering and theory, so you can simply uh, visit to the channel and get that video. Okay, so let's see the numerical. So we have given numerical here. The cultivable command area of a water course in 1200 hectare. Okay, so we have given cultivable command area. Simply we can write here CCA equal to 1200 hectare. Intensity of sugarcane and wheat crops 20% and 40% respectively, and the intensity is given. Intensity for sugarcane equal to, we have given here 20%, and for the wheat it's given 14% respectively. The duties for the crops at the head of water course are 730 hectare per cumex, and the duty is given over here is 730 hectare per cumex and 1800 hectare per cumex respectively for the sugarcane and wheat. So we just write here the duties of sugarcane and wheat equal to 730 and 1800 hectare per cumex. Okay, so this is also given in the question, and now we have to find the discharge required at the head of water course, and in second number determine design discharge at the outlet. So we have to calculate these two value. So as we see, this value are given in the question, and this is also the cultivable command area is given 1200 hectare. Okay, so simply we can calculate the area to be irrigated under sugarcane. For the sugarcane, we can calculate the area equal to simply the duty is multiply the intensity percent. Okay, so we have we have total area equal to 1200. Okay, but for the intensity for sugarcane equal to only we take 20% of area, so we have to just multiply with this value. So the value equal to 0.2, and after calculating the value of area to be irrigated for the sugarcane equal to 240 hectare, and in same way the area to be irrigated for the wheat we can calculate 1200 by the intensity of wheat, that is 40%, and simply we take the value of 40% as 0.4. Okay, so the area of calculated for the wheat equal to 480 hectare. And one thing you have to know, after adding these two value for the sugarcane and for the wheat, the value must equal to the total value. Okay, total value of culture command, that is 1200. So let's sum this value after calculating, adding this value, that is 480 and 260. The value this becomes 480 plus 240. The value becomes simply and this value becomes 720. Okay, we have the overall area is 1200 hectare, but we only take the 60%. That's why the total area after adding the sugarcane and wheat becomes 720 hectare. Okay, as you know, and now we have to duty of sugarcane equal to 730 hectare per cumex. This is already given in question. You can see here the duty of crops at head of water course and respectively. Okay, so for sugarcane equal to 730 hectare per cumex, and for the wheat 1800 hectare per cumex. Okay, now we can simply calculate the value of discharge for required of sugarcane equal to simply we have to divide area by the duty. Okay, so we have already calculated the area, and the area calculated for the sugarcane equal to 240. So we just take area equal to 240, and duty is given by the question, and duty of sugarcane equal to 730. Just we have to divide for get the discharge. okay, for getting discharge. So we get the value of discharge for the sugar cane equal to 0.33 qmap, and for the discharge of wheat equal to area by duty, as we done previously for sugar cane. So the value of area for wheat equal to 480. Okay, you can see here 480 hectare we have calculated, and duty is given by the question, that is 1800. Okay, you can see here 1800 hectare respectively. So that value is taken here. So the value of which becomes 0.27 in qmap. Simply qmap means meter cube per second. Okay, as you know, the value of 0.33 meter cube per second. Simply it is called qmap, and 0.27 meter cube per second. Okay, this is also in meter cube per second. Okay, so we have already calculated the discharge of sugarcane and for the wheat. Now as we have to determine the discharge required at the head of water course. Okay, for as sugarcane is a perennial crop, as we know sugarcane is a perennial crop, and wheat requires water for only rabi season. Okay, but for the wheat it only require water in rabi season, but sugar can be this is perennial crop. Okay, and that's why the water required for the crop at the head of water course, simply we have to add these two value. So as we calculated the discharge for the sugar cane equal to 0.33 plus discharge for the wheat 0.27. So we just have to add these two value. After adding these two value, we will get 0.63 qmac. Okay, so we have calculated this discharge required at the head of water course. Okay, so simply we can say discharge required at the head of water course. Okay, and it becomes 0.6 qmac. And in second number you can see here we have to determine the design discharge at the outlet. Okay, for this design discharge of outlet we have to take the time factor, that is 0.8, since channel runs fewer days than the crop days. Okay, why we take on 0.5? Because the channel runs fewer days than the crop days. Okay, that's why we take the value 0.8, and discharge design discharge at the outlet equal to simply design discharge at outlet we can calculate by discharge required at head of water course with the we have to divide this value with time factor. Okay, time factor. Okay, and the time factor is simply 0.8. So the value of discharge required at the head of water course we have already calculated, that is the value of this became, you can see here, 0.6. Okay, so simply we have to divide 0.6 with time factor as we take the time factor equal to 0.8, the value of design discharge at outlet becomes 0.75 meter cube per second. Okay, in this way we can calculate these two value. Okay, as I said in question. So we can simply calculate this value. So let's summarize. First thing, we have to know about the calculating the area. Okay, so simply you can calculate the area with the given intensity. Okay, so we have to multiply these two value, and after calculating the area we have to calculate the duty for different that is in this question sugarcane and wheat. So we calculated duty, and this duty is may given to the question. In this question already the value of duty is given. Okay, and after that we have to calculate discharge required for different for the sugarcane and wheat. So you can simply calculate discharge by the dividing of area by duty. Okay, area by duty gives the value of discharge. After this value, simply we have to add both these two value, then we get total discharge. Okay, so in this way we can calculate different parameter asked in question. Okay, so I hope guys you will understand well. Thank you very much. If you have any queries, please comment down below. Thank you very much. See you in next video. Okay, and for the basic concept, I have already done some basic concepts, and also the relation between duty delta and base period as in previous video. So you must see the previous video. Thank you very much. See you in next video. Okay, and next video we will also do different numerical related to this topic. So you have to see this video too. Okay, so stay tuned. Thank you very much. See you in next video.